Hi, this is Dr. J. Nityapriya, Assistant Professor, Department of Computer Science, JJ College of Arts and Science, Autonomous, Pudukkottai. And I'm so happy to see you in this video. In this video, we're going to see about a knapsack problem. And these are the contents of this presentation. Fractional knapsack we are going to see with example, and nextly we're going to see a 0 or 1 knapsack with example. Right. So let me explain about knapsack problem. Okay. So knapsack is a problem in which sack will be given, a bag will be given. Knapsack is a bag. Okay. The bag will be having a capacity, and the capacity will be designated as M. Okay, M is the capacity of the bag. The capacity will be different for different bags. Sometimes it will be 10 kg, sometimes it will be 15 kg, sometimes it will be 20 kg. It depends upon the bag. Okay, so M is the capacity. Nextly, the problem is we have to fill up the bag according to the capacity. How can we fill up? We can fill up the bag up to the weight which is equal to the capacity. Okay, we can fully fill up the bag, or we can partially fill up the bag. In a bag which has 10 kg capacity, we can put 9 kgs weight also, right? We can put 10 kgs weight also. We can also put 8 kgs weight also. So in different ways we can fill up a bag, right? But no way we can put 11 kgs inside the bag which has the maximum capacity 10 kg. Okay, so that is the constraint. We have to fill up the bag only which is only equal to the capacity or less than its capacity. That's it. Okay, and talking about the items, there will be number of items. So number of items will be n. N is the number of items given. Okay, if 3 items are given, n is 3. If 4 items are given, n is 4, right? For every item, there will be a weight and there will be a profit. Okay. For every weight, there is a profit, right? So knapsack problem, in knapsack problem, when we put a weight inside the bag, the particular profit will be gained. For example, for 5 kgs, the profit would be 10 kg. If you put the 5 kgs inside the bag, the whole 5 kgs inside the bag will gain the maximum profit of the particular item, which is 10. Okay, so that is about the thing. If you put the weight, if you pick the weight, the particular portion of the particular profit you will gain, right? So knapsack has two types. Okay, one is fractional knapsack, another one is 0 or 1 knapsack. In fractional knapsack, you can pick a weight in its portion also. For example, if in a bag the bag's capacity is 10 kg, you have tomatoes and sugar. Okay, you have 10 kgs of tomatoes and 10 kgs of sugar. For 10 kgs you will have 20 profit. 10 kgs of tomato you have 20 profit. For 10 kgs of sugar you have 30 profit. Let's take like this. Okay, for example, you are filling up the tomato with only 5 kgs. Out of 10 kg tomato you are picking only 5 kg. So how much profit you will gain? Okay, half of its profit. The same thing happens for sugar also. How much portion you are taking, that much portion of profit you will gain. Okay, so that is about fractional knapsack. So fractional knapsack allows us to take portion of weights. Talking about 0 or 1 knapsack, 0 or 1 knapsack doesn't allow us to take portions. Okay, either we are taking it or we are omitting it. That is about 0 or 1 knapsack. Okay, right. So fractional knapsack. Now the firstly we say fractional knapsack. Okay, so everything I've explained. M is the capacity and W is the weight. Okay, Wi is the weight of a particular object I. Okay, here it is object I and its weight is Wi and so on, right? So if a portion which is Xi of object I is placed into the knapsack, the profit Pixi is earned. Okay, how much portion you have taken, that much portion of a profit you are gaining. That's about that. So as I said, the objective is to filling the knapsack which maximize the total profit. So actually the problem says when you fill up the bag, you'll gain a profit. Okay, you can fill up the bag in many ways. Okay, so whichever the solution is, whichever solution gives you the maximum profit, that is declared as the best solution. Okay, normally we solve this fractional Knapsack problem in greedy. Okay, so greedy gives us two types of solutions, one is feasible solution, another one is optimal solution. Feasible solution is what are all the possible ways to fill up the bag, that are all considered as feasible solutions, and the best feasible solution is considered as the optimal solution or the exact solution. That's it. Okay, so that is how we are going to solve this fractional Knapsack problem, right? So the constraints or the conditions we are going to say, we have to maximize the profit. Okay, the profit is it is calculated as summation of PIXI, where I stays in between 1 and n. N is the maximum number of items, right? So M is the summation of weight. Okay, if you take a portion, it will be WIXI. X is the portion, right? So that is how these are the two constraints, right? So consider this problem, right? What is N? N is 3. What is M? The capacity, it is 20. Okay, and the profits of the N items, 3 items are P1, P2 and P3. The profits are 25, 24 and 15. And about the weights, W1, W2 and W3, they are 18, 15 and 10. Right? So I know I think you understood all the important things in the problem given. Okay, M, which is the capacity, N is the number of items, and P is the profit, W is the weight. Okay, for this problem we can give 4 feasible solutions. They are, firstly, 1 by 2, 1 by 3, 1 by 4. On the heading we have x1, x2, x3. Okay, x1 the portion of the first weight, x2 the portion of second weight, x3 is the portion of third weight. Okay, that is it. WIXI is the summation of the weight. PIXI is the summation of the profit that we have taken. Okay, so if the first solution is 1 by 2, 1 by 3, 1 by 4, that is half of the first weight and 1 by 3 of the second weight and 1 by 4 of the third weight are taken. Okay, so the weight will be 16.5. It is calculated. I have given how it is calculated in the hint. Okay, see the hint, which is in blue color. 1 by 2 into 18, which is the first weight, plus 1 by 3 into 15, which is the second weight, 1 by 4 into 10, which is the third weight. Okay, so when we sum up everything, we get 16.5. The same thing is applied for calculating PIXI also. Okay, so for the first solution, the profit would be 24.25. Okay, see the second one, 1, 2 by 15, 0. Okay, so that's it. If we take like that, the weight would be 20 and the profit would be 28.2, right? So see the third solution, 0, 2 by 3, 1. Okay, so if we do so, the weight would be 20, the weight filled will be 20 and the profit would be 31. Okay, see the fourth solution, we just ignore the first item and we take the second weight as the whole, 15, and the third weight, the capacity is 20. Okay, we have put 15, and how much is remaining? Remaining we can fill up? We can fill up only 5 kg inside the bag. Okay, so we take the half portion of the third weight, which is 10. So out of 10, 5 we take. Okay, so if we do so, the weight will be 20 and the profit gain would be 31.5. Okay, so these are all about the feasible solutions of this problem, right? Now see the profits. Now we are going to find out which is the best solution. See the profits. Number 4 has the maximum profit, which is 31.5, and that is declared as the feasible solution, optimal solution. I'm sorry, right? So how come we calculate the optimal solution? They may be number of solutions given for a problem. Okay, here we have given 4 solutions. There may be 40 solutions for the problem. All the 40 solutions we cannot write. Okay, because only when we write, we'll find out the optimal solution, right? So there should be a formula or the technique to find out the optimal solution. Okay, so what is that? We see here. First, we have to rank the items. depending upon the profit and weight ratio of the items. Okay, the profit weight ratio is calculated as pi by wi. P stands for profit and weight, w stands for weight. pi is profit of item and wi is weight of item. Okay, so now we calculate, we have three items, we calculate p1 w1, p2 w2, p3 w3. Okay, so count the ratio of all the three items. For the first item, the ratio gives 1.4. For the weight 25, for the weight 18, the profit is 25. Okay, so the ratio is 1.4. For the weight 15 w2, the profit is p2 and the ratio is 1.6. For third item, the ratio is 1.5. Okay, so see the ranking. Okay, the greatest ratio is 1.6 for the second item, and the second greater is the third item, which is 1.5, and the third item is 1.4. Okay, right. So according to the value of the profit weight ratio, we rank the items. So rank 1 is given for the second item, rank 2 goes to the third item, rank 3 is given to the first item. Okay, so if we pick the weights according to this order, we'll gain the optimal solution, right? So when we pick up items according to their rank, it will give us the optimal solution. Surely it will give us the optimal solution. See solution number 4, that is the optimal solution. Okay, we take the second item first as the whole, 15, and the remaining 5 we take from the third weight. From 10 we take 5 and just we fill up the bag. Okay, the bag is full, so we just ignore the first item. Okay, so if we take like that, the bag is full with 20 kg and the profit we gain is also the maximum. Okay, this is how we get the optimal solution, right? Now we firstly see 0 or 1 knapsack. So we finally understood what knapsack problem is, and 0 or 1 knapsacks are just that we take the item or we ignore the item. That's it. We cannot take the fractions of weights. Okay, that's it. So in this given example, there are 4 items and the sack's capacity or the bag's capacity is 9. The weight is W1, W2, W3, W4. They are 3, 4, 5, 6 and the profits would be 5, 6, 7 and 11. Okay, so these are the feasible solutions. We take the first item and we take the last item and we just ignore the second and third. Okay, so the weight we gain is 9. We know the capacity is 9. Okay, so the sum of the profit is 16. Okay, the second feasible solution would be 0, 1, 1, 0. Okay, the sum would be 9 and the sum of profit would be 13. Okay, just see. This is the problem. Okay, remember this is the problem, right? So if we take the first item and the second item, I just go backward. If we take the first and the second, okay, the weight gained would be 7. Okay, and the profit gained would be, see this slide, you can say it would be 11. Okay, and if we take the first and the third item and we just ignore 2 and 4, the weight gained would be, see here, I go backward, first and third, 3 plus 5, 9 we gain and the profit will be 5 plus 7 will be 12. So like this we can give various solutions and we gain the profits according to the weights that have been taken. Okay, so the profit by weight ratio, so like we can give various feasible solutions, and now we move on to finding out the optimal solution. How do we do that? We just rank, okay, according to the profit and weight ratio. Okay, so we do that the same way we did in fractional knapsack. So the rank will be given. See the fractions for the fourth item. There is the maximum profit by weight ratio, and for the first one it is 1.6, for the second it's 1.5, the third one is 1.4. So the rank is 2, 3, 4, 1. So if we take the items according to its rank, we'll get the optimal solution. So this is the optimal solution because the profit is the maximum. Okay, so I hope you understood the problems of fractional knapsack and 0 or 1 knapsack. Thanks for watching this video. Thanks a lot.